Hello, I welcome you all. The problem reads the telephone pole of negligible thickness is subjected to the force of 80 pounds directed as shown. It is supported by the cable BCD and can be assumed pinned at its base. In order to provide clearance for a sidewalk right of way where D is located, the strut CE is attached at C, is shown by the dashed lines. Cable segment CD is removed. If the tension in CD prime is to be twice the tension in BCD, determine the height for placement of strut CE. Right. This problem is coming from the engineering mechanics statics textbook, 13th edition by R.C. Hibbeler. We have a pole. Okay, this pole is being supported by cable BCD. Okay, and we are assuming the support at A is pin support. So by pin, it means we only have reactions in the horizontal direction like so, and in the vertical direction like so. Either way, but we don't have any moment. No moment. All right. So there's need to this area here, D prime. They want to use it for as a way, some right of way. They want to clear it for a sidewalk. So they want to change this cable CD so that it makes a turn, it follows this dashed line, and then they will place some strut here. Okay. So we've been told that if they did so, we are assuming that the tension in CD prime in here, the tension in CD prime is going to be twice the tension in BCD. So if the tension in BCD is T, therefore the tension there is going to be 2T. This is what we are being told. All right. So now the question is to find the height H. Okay. So that we know exactly where the strut CE is going to be placed. Right. Okay. So let me redraw the free body diagram. So we are saying A is assumed to be a pin. So we only have a reaction force A, Y, and AX. Of course, we are not going to use this, but I'm just indicating. Right. The tension in BC, I'm saying the tension there, the tension in BCD, we are taking it as T. Let's call it T. So if you have the tension in BCD, the tension in the new cable, okay, that will make a turn at the strut, at the connection point of the strut C, going down like this in green. The tension in CD prime is going to be equal to 2T. That will be the tension there. All right. So now we are being asked to find the height H. Okay. So before I do the calculation, let me give you the concept of exactly what we're going to do. So this pole is in 2D, which makes the work easier. And all the forces are in 2D in our X and Y. And this is our coordinate system, X, Y, positive, and moment anti-clockwise like that. So tension in BCD, we are calling it T. and tension in CD prime, we are calling it will have 2T. Okay, so when you look at this whole system where the strut is placed in H, this is a concept of similar triangles, right? Similar triangles. So we have a system like this. Okay, so this is B, this is A, this is E, this is C, this is here D, this is D prime. Alright, this height here is H. Okay, is H. This is what we want to find. And this whole height here is just 1 minute. Okay, then this height here up to there, this is going to be equal to 30 minus H, because the whole height, this whole height here is 30 feet. This DA is 10 feet. Okay, right, just 10. Okay, we know it's feet. So this is the information that we have right now. So what we are going to do is we are going to apply similarities of triangles. So we'll say BE, okay, divided by BA is equal to, so BE divided by BA will be equal to CE divided by DA, right? You know about this, right? So BE, what is BE? Our BE is 30 minus H. 30 minus H. What is our BA? Our BA is 30. So this is going to be equal to, what is our CE? CE, we just CE. What is our DA? Our DA is 10. Alright. So let's make CE subject to formula. 10 can cancel there. So we have a 3. Then 3 there. 1, 3 there. 10. And then 3 there. We have H over 3. Right? And therefore our CE is going to be equal to, our CE is going to be equal to our CE is equal to 10 minus H over 3, right? And if we also made, because we also need H later on, our H is going to be equal to, we need H also. Our H is going to be equal to 10 minus CE, then everything we are multiplying them by 3. Okay, right. So this is our H. Okay, right. So now what we are going to do is we are going to find T. We'll find T, then later on by taking moments about A, and once we've done that, we'll come and again recalculate this using 2T. Alright. The slope for this BD is, this one here is 10, this is 30, therefore this here hypotenuse this one here, the hypotenuse, this one is going to be equal to what is it? It's 10 squared plus 30 squared, root of that. So this one is root of 1000. Okay, squared plus 10 squared, root of 1000. Right. So now let's take moments about point A. So we'll say summation of moments about point A is equal to 0, and clockwise being our reference positive. Okay, so we want to find T first. Okay, imagine this CD prime is not there for now. We first want to find T, the tension force in cable BCD. Okay, we need to have that information first. So imagine we need to have that, and then we later on input it in the planning where we'll need to change the orientation of the cable. So let's find the tension in BCD. So taking moments about point A, this force here is going to have two components. It will have a component there, and this component there, it is 80 cos 30. Okay, and then there's going to be another component in this direction like this. This one is going to be equal to 80 80 sine 30. This cable also will have components. It will have one component this side, and this force here is going to be equal to, call it the tension in E, we just call it T. So it will be T times, we have this slope, so it will be 10 divided by root of 1000, right? Divided by root of 1000, and then it will have another component, this one is going to be equal to T times 30 divided by root of 1000. All right, the vertical components will not have an effect on the moment, only the horizontal ones, right? Because those ones are centric, they are passing through point A, so they will not have an effect in causing the moment. Right, so having done that, let's now do the calculation of our moment. So 80 is going to cause clockwise, which is negative, so it will be minus 80 cos 30 times the lever arm about point A is 30, then plus T is the tension force in BCD. So we are saying force BCD in this case is equal to T. This is what we are saying. Okay. So T times 10 divided by root of 1000 times the lever arm, which is 30, is equal to 0. So let's make T subject to the formula. Grab your calculator, make T subject to the formula. Okay, there we go. So we have 80 cos 30. Okay, of course the 30s are going to cancel out, divided by 10 divided by root 1000. Right, what do we have? We have a 219. We have a 219.09 pounds. Okay, let me recalculate it again. 10 root 1000 and then we have 80 cos 30, 219.09. All right, so we have t. So with that in mind, we'll need now to find we'll need now to imagine that we have now changed the cable at point C, we've moved D to D prime. All right, so this one was case number 1. Case 1. Case 2, we have moved D to D prime because we want to create some space. Okay, we want to clear that space maybe for a sidewalk or something else, but we need to move this point of the cable to D prime. So if we did so, we've been told the tension in C D prime will be twice the tension in BCD, and we found the tension in BCD, which is 219.09 pounds. So now let's take moments here due to the new cable now. Okay, new cable, that is cable BCD prime. Okay, and we've been told the tension in CD prime is twice the tension in BCD. So taking again, and case number 2, taking moments about point A, due to the force CD prime, we are going to have this. So summation again of moments about point A, due to case number 2, we have minus 80. This force 80 is still there, nothing has changed. We have just been moving the cable. 80 cos 30 times 30, okay, and then plus 2t. This one, the 2t is going to cause anti-clockwise. 2t times CE, okay, times the lever arm CE, okay, CE, which is equal to 0. Mind you, we found already what CE is. We said CE is going to be equal to this. Remember this? Okay, so we just get this and come and plug it there. Right. So, and we already know what T is. We said it's twice, and our T, we already calculated what T is. This is the T here. This was our T here. Right. So this one also, we just get this. We'll get this T and come and plug it where? Here. Is that fine? It is. Great stuff. So if we did so, then we can find what CE is. So making CE subject of the formula, CE is going to be equal to 2 by 2t, that's 219 by 0.9 by 2. It gives us a 438.178. And then a minus, we have 30 times 80 times cos 30, right? No, sorry. So we have 30 cos 30, 80 cos 30 times 30, okay, and then divided by 2t. That's a 2 times 219.09. Yeah. So what we have, our CE is 1.178. Okay, let me come back again. So we have 80 cos 30 times 30 divided by 2 times 219.09. What happened? 80 cos 30 times 30 divided by 2 times 219.09. Okay, no, not this. What was I calculating? It's giving me a 4.74. Alright, 4.74, that's CE, okay, and this is in feet. Alright, so once we have this, then we've been told, or we have done our calculation ourselves, to say H is going to be this. Okay, so we use this equation now, which we found, okay, and replace our CE there. So H is equal to 3 times 10 minus CE. Therefore, 3, 10 minus CE, which is a 4.74. So this is equal to, let's calculate, 4.74. 10 minus 4.74, then times 3. What do we have? We have a 15.78. 15.78 feet. Alright. Okay, so therefore our H is equal to 15.78 feet. Okay, 15.78 feet. Right, I guess we are done, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, share my video, and subscribe to Benam Academy. Bye bye, and see you in my next screencast.